we'll come back to them. Hopefully, I don't forget, because if I forget, we're going to end up with quite a few errors in our code. So we'll move on. Create a new function here, function called process, with an argument delta, which is a float. For now, we can just say pass. Good. We'll come back to it. So the things that we want to do is, here we want to have the logic for moving, or we'll call the functions for moving the paddle and moving the ball. So this function process, it's a system function, and what it does is that it is called in every frame of the game. That's why this delta, this argument delta is here. So it's called every frame of the game, and delta is the time between the previous frame and the current frame of the game, right? So we'll be calling the functions for moving the ball and moving the paddle here in the process function. So let's move on to something else. We'll call it layout. I can't even see what I've typed. Layout cut. Oops. Oh, I don't see out of function declaration. Yeah, it's indented, is it not? Okay, let me just type. Yes, the error is gone. So we want to get viewport. So to get viewport is you're getting the size of the screen on which the game is being played. It's going to be played on different kinds of screens. So what this statement is saying is we're going to get the size of the screen on which our game is being played. If it's on the phone, different mobile phones have different screen sizes. Even different computers, different laptops have different screen sizes. So we want to get that screen size. Then what do you do with it? Uh, dot position. Yeah, we want the position to be a vector 2 and at 0, 0. And then what's going to be the size of our background? So background.size is going to be the size of our screen. So we just say screen as we've declared it here. So it's saying value of type rect 2. Oh, okay. So here, hopefully that, yes, it takes care of. So we're getting the viewport and then the size of the viewport. So this should now be good. The error has disappeared. So let's set the dimensions of the center line. So the size is what? Center line, the size. So the size of our center line, we want to make it just just thick enough, so maybe 4 pixels, and then that's for the width. And the height, we want to make it the size of the screen, whichever screen our game is viewed on. It's going to run from the top of the screen to the bottom of the screen. So we say screen dot y for y-axis. Good. And then now, where are we going to position this center line? So we want to have it at the exact center of the screen. So we say screen.x over 2, which is half of the screen. And then we minus the width, half the width of the center line. So center line size dot size dot x, and we divide that by 2.0, then 0. Yes, that works. And then the function of the position of our score label. The position is going to be what? And then on the x-axis, we want to have it at the very top. And then on the y-axis, maybe 0. Wait, what am I saying? Not 0. 0 is already the first one. Maybe something like 18. Then the size of the score label. It's also going to be a vector 2, and the dimensions here, or the arguments here, are going to be screen x and a random position, maybe 70 pixels from the top. So this is a process function. No, this is a layout. Oh, okay, yeah. And with that, we have our layout function for our game. What next? Next, we want to have the logic for moving the paddle. So move paddle. So this is one of the functions that you want to call from the process delta. So it's going to take an argument delta. And it's going to be void. Void just means it does not have a return value. Like after it has worked, after it has gone, it has processed whatever it's supposed to process, it's not giving us any return value. So we declare the variable screen again here in this function, and it's going to be get viewport dot size. Pardon any noise that you might hear coming through. Just bear with me. So we declare a variable here, left direction. We just call it left dir. It's going to be 0.0. Then here Now, what you want to do is we learned something very cool in Godot, which is how to log input from the user or how to get the input from the user. Is the user pressing the up button? Is the user pressing the down button? What input is the user applying into the game? So we're gonna say if input that is key pressed. Yes, and we want key what? Key W. There we go. What happens? So we want left direction to increase to left direction to decrease by 1 pixel. And remember, this is happening for during every frame of the game. So this is basically if our game is running at 60 FPS, it's going to be happening at around 60 times 60 times per second, which is 60 pixels every second, 60 pixels on the screen. Still have a bit of code left, but I'll try and hurry things along. So we do that for the Control C for the other direction as well. So we want it to be key S. What do? We add. Good. This is for the left paddle, right? Now we want to do the same for the right paddle. So I can just copy this code just to make things a bit faster. Control C, Control V. But now here we say right. So this is going to be key up. It's going to be key down. So, and this is the right direction. Right direction. Good. And then now we can go back and call our function for move paddle. So where is our process delta? So we'll instead of pass now we can call layout code and move paddle. Good. We'll call it delta. Yeah, we'll pass on delta. Good. Our move paddle function still needs some bit of code.